Hello, we are going to continue from the last video. The method of Lagrange multiplier. In order to find out the maxima or minima, we have to use the method of Lagrange multiplier, which is equal to del f equal to lambda into del g and g of x, y, z equal to 0. We have done already this problem. We have discussed this problem f of x, y equal to x, y and the g equal to x square by 8 plus y square by 2 equal to 1, and we have got the answer that's equal to either points plus or minus 2 1 plus or minus 2 minus 1. These points, this function have maximum and minimum value. This function have maximum and minimum values. Next question I would like to discuss with you, that is, find the maximum and minimum values of the function f of xy equal to 3x plus 4y on the circle x square plus y square equal to 1. That is f of xy equal to 3x plus 4y, g of xy equal to x square plus y square minus 1, which is equal to 0. And we have to find the values of x, y and lambda. This is a procedure actually. First write down the f of x, y. Next the condition means that is g. Next we need we have to write. These we have to write, that is, find x, y and lambda that satisfy the equations del f equal to lambda del g and g of xy equal to 0. That is, del f equal to 3i plus 4j equal to 2x lambda I plus 2y lambda into j. Right? And g of xy equal to 0 implies x square plus y square minus 1 equal to 0. Right? And this implies what we will get from this equating the right and left side, ith coordinate equating 3 equal to 2x lambda and 4 equal to 2y lambda. From that, x equal to 3 by 2 lambda and y equal to 2 by lambda. Right? And these equations, from these this x and y are x equal to 3 by 2 lambda, y equal to 2 by lambda. This must satisfy this equation. Okay, so I'm substituting this x equal to 3 by 2 lambda, 2 by lambda in this equation. This equal to 0. And then 9 by 4 lambda square plus 4 by lambda square equal to 1. Right? 4 lambda square, taking LCM on both LCM, then 4 lambda square is LCM, then 9 plus 16 equal to 4 lambda square. That's 4 lambda square equal to 25 and lambda equal to plus or minus 5 by 2. Then what happened to this x? X equal to 3 by 2 lambda. Then this is equal to, I'm substituting this lambda equal to plus or minus 5 by 2. Here this is equal to plus or minus 3 by 5. Similarly, y can be get by substituting lambda equal to plus or minus 5 by 2. So this is equal to 4 divided by 5. So x equal to plus or minus 3 by 5 and y equal to plus or minus 4 by 5. Okay. So the points are 4 type of points we have. First of all, I'm taking the positive only. 3 by 5, 4 by 5. Next 3 by 5, minus 4 by 5. Next minus 3 by 5, 4 by 5. Again, the last one is minus 3 by 5, minus 4 by 5. Okay. So substitute these values in this f. Okay. And find out the maximum value of f and the minimum value f. f has maximum when x equal to positive 3 by 5, y equal to positive 4 by 5. And f has minimum value when x equal to minus 3 by 5 and y equal to minus 4 by 5. So f of xy equal to 3x plus 4y has extreme value, that is maximum value at 3 by 5, 4 by 5, minimum value at minus 3 by 5, minus 4 by 5. Okay, the maximum value is 5 and minimum value is minus 5. Okay, is it clear? Right. So next, do the problems in the exercise also. If any doubt, please ask me. Okay. So next, I would like to explain about the Lagrange multiplier with the two constraints. That means the same as in the above case. That means many problems requires us to find extreme values of the differentiable function f whose variables are subject to two constraints. If the constraints are g1 of xyz equal to 0 and g2 of xyz is equal to 0. G1 and G2 are differentiable with del G1 not parallel to del G2. G1 of xyz equal to 0 and G2 of xyz equal to 0. G1 and G2 are differentiable with del G1 not parallel to del G2. This is the condition. Okay. In this type of problem, that is f 1f differentiable function f with two constraints g1 and g2 and del g1 not parallel to del g2. How to solve this type of problem? In order to that, our procedure is, we have to write first. Our procedure is finding the values of x, y, z, lambda and mu that satisfies the equation del f equal to lambda del g1 plus mu del g2, and next condition is g1 of xyz equal to 0 and g2 of xyz is equal to 0. Del f equal to lambda del g1 plus mu del g2. Okay, and g1 of xyz equal to 0, g2 of xyz equal to 0. Okay, we can explain this through an example. The plane x plus y plus z equal to 1 cuts the cylinder x square plus y square equal to 1 in an ellipse. Find the point on the ellipse that lie closest to and farthest from origin. The plane is x plus y plus z equal to 1. Cuts the cylinder x square plus y square equal to 1. These are the two conditions. What we have to find out? Find the points on the ellipse that lie closest to and farthest from origin. Okay, we have to find a point at which, that is, we have to find a distance from origin to a point such that that distance is origin to ellipse such that that distance is minimum and maximum. Okay, so I would like to take f of xyz equal to the distance between the point. Let xyz be the point on the ellipse and origin is here. We have to find the distance from origin to that point on the ellipse. So the distance equal to square root of x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. That is square root of x square plus y square plus z square. So in this, we have to take this f of xyz equal to x square plus y square plus z square. Subject to the constraint g1 equal to x square plus y square minus 1 equal to 0 and g2 equal to x plus y plus z minus 1 equal to 0. So we have to write this one, that is del F equal to lambda del G1 plus mu del G2. Del F equal to lambda del G1 plus mu del G2. Okay. So find this del F. Del F equal to this one. 2xi plus 2yj plus 2zk equal to lambda into 2xi plus 2yj plus mu into I plus j plus k. That's equal to 2 lambda x plus taking I coordinate of combining this I coordinate, j coordinate and k coordinate. So 2 lambda x plus mu into I plus 2 lambda y plus mu into j plus mu into k. Okay. So equating on both sides 2x equal to 2 lambda x plus mu. 2y equal to 2 lambda y plus mu. And 2z equal to mu. Okay, 2x equal to 2 lambda x plus 2z implies 1 minus lambda into x equal to z. From 2y equal to 2 lambda y plus 2z, we have 1 minus lambda into y equal to z. Okay. This is equal to, this is which are equal, that is 1 minus x into x equal to 1 minus lambda into x equal to 1 minus lambda into y, that is 1 minus lambda into x minus y, which implies 1 minus lambda equal to 0 or x equal to y, right? So if lambda not equal to 1, this is x equal to y, which is equal to z divided by 1 minus lambda. If z equal to 0, z equal to 0 means lambda equal to 1. When lambda equal to 1, z equal to 0. If z equal to 0, equation 3 and 4. X square plus y square minus 1 equal to 0. X plus y equal to 1. And what happened to this one? The points are 1 0 0 0 1 0. The points on the ellipse gives, that is 1 0 0 0 1 0. If x equal to y, then the equations 3 and 4 give x square plus x square minus 1 equal to 0. This is from this x equal to plus or minus root 2 by 2. This is 1 plus or minus root 2. So the corresponding points on the ellipse. So if z equal to 0 here, this does not happen. This cannot be, we cannot take these values. Why? You just to think it. So P1 equal to here, the P1 equal to root 2 by 2, root 2 by 2, 1 minus root 2. P2 equal to minus root 2 by 2, minus root 2 by 2, 1 plus root 2. P1 and P2 are both giving local maxima and of f on the ellipse. P2 is farther from the origin than P1. Okay, this is the example corresponding to the Lagrange multiplier with a 2 constraint. Okay, so we can do some more problems in this exercise. Right, you do it, and if any doubt comes, please ask me. Okay, so I also explained this problem in detail through another video. Okay, thank you.